For decades, humanity has gazed at the moon, a celestial body so close yet so distant in our collective memory. Many believed we'd return swiftly after the Apollo missions. Those monumental strides in the 1960s and early 1970s that saw humans first set foot on its dusty surface. Yet, here we stand in 2025, over half a century since Apollo 17's departure in 1972, with no human having walked the lunar landscape since. The moon, once a beacon of human achievement, became a distant dream, its allure overshadowed by the complexities of space exploration. But now, the tides are turning. A renewed fervor grips the global space community, driven by a bold vision not just to revisit the moon, but to use it as a springboard to destinations far beyond. This is no mere nostalgia trip, it's a calculated step toward a future where humanity becomes a multi-planetary species. Stay with us as we dive into the cutting-edge technologies, the ingenious minds, and the audacious plans propelling us back to the moon and onward to Mars. The moon, in its stark, cratered beauty, is more than a destination. It's a proving ground. Scientists and engineers at NASA, alongside private innovators like SpaceX, Blue Origin, and international partners, are rekindling the skills lost since Apollo. The Artemis program, NASA's flagship lunar initiative, aims to land the first woman and the first person of color on the moon by 2026, establishing a sustainable human presence by the decade's end. This isn't just about planting flags, it's about building infrastructure, habitats, power systems, and resource extraction methods that will make the moon a stepping stone to deeper space. Why the moon? Because its proximity, just 384,400 kilometers away, allows us to test technologies and strategies in a harsh environment before tackling the far greater challenges of Mars. The moon's reduced gravity, 1/6 that of Earth's, and its abundant resources like water ice and shadowed craters make it an ideal laboratory. But the journey isn't easy. We're relearning how to live off-world, and every step forward is a testament to human ingenuity. Keep watching to see how we're turning lunar dust into the building blocks of tomorrow. If the moon is our training ground, Mars is the ultimate frontier. Orbiting at an average distance of 225 million kilometers from Earth, Mars is tantalizingly close, yet dauntingly far. It's the most Earth-like planet in our solar system, with polar ice caps, ancient riverbeds, and a day just 40 minutes longer than ours. Its rusty red surface, colored by iron oxide, whispers of a past where liquid water may have flowed freely, perhaps even nurturing life. Unlike the moon, Mars offers the possibility of a new home for humanity, a place where we could one day establish a self-sustaining colony. But almost habitable is a far cry from welcoming. Mars' thin atmosphere, just 1% of Earth's pressure, offers little protection from cosmic radiation. Its surface is frigid, averaging -80 degrees Fahrenheit, -62 degrees Celsius, and dust storms can engulf the planet for months. Yet these challenges only fuel our determination. Mars isn't just a destination, it's a call to our species' exploratory spirit. Join us as we uncover the bold plans to conquer the red planet. Why Mars? Because it's the next logical step. No other body in our solar system offers such a compelling mix of scientific potential and habitability. Venus is a hellscape with crushing pressures and temperatures hot enough to melt lead. Mercury is too close to the sun, and the outer planet's moons, like Europa or Titan, are too distant and frozen. Mars, though, is within reach. NASA's Perseverance rover, roaming the Jezero crater since 2021, has already found evidence of ancient water and collected samples that could hint at past microbial life. SpaceX's Starship, a fully reusable rocket designed for interplanetary travel, aims to carry humans to Mars as early as the 2030s, with Elon Musk envisioning a million-person colony by 2050. But getting there is only half the battle. Surviving, thriving, and building a new world on Mars demands technologies we're only beginning to master. From robotic miners to 3D printed habitats, the tools we're developing are nothing short of revolutionary. Stick around to see how we're transforming science fiction into reality. The moon is more than a nostalgic revisit, it's the key to unlocking Mars. NASA's Artemis base camp, planned for the lunar South Pole, will serve as a testbed for technologies critical to Martian exploration. The moon's surface, covered in regolith, a fine abrasive dust rich in silicon, oxygen, and metals, holds the raw materials for building off-world. Imagine robots scouring the lunar landscape, mining regolith to construct habitats, landing pads, and even roads. These aren't sci-fi fantasies, they're projects in active development. At NASA's Kennedy Space Center, engineers like A.J. Nick are designing robots that can operate in the moon's weak gravity, where objects weigh just 1/6 of their earthly mass. These machines must be lightweight to fit inside rockets, yet robust enough to handle the lunar terrain's challenges. Let's take a closer look at one such innovation, a rover that redefines how we dig in space. Picture this, a compact, rugged robot rolling across the moon's surface, its dual scooping drums spinning in opposite directions. This isn't your average rover. It's a marvel of engineering designed to tackle the moon's unique environment. I had the chance to test one, guided by robotics engineer A.J. Nick. With a flick of a switch, the rover hummed to life, its arm raised, ready to dig. The controls were intuitive, 2 joysticks, one for each side of the wheels, offering a surprising sense of stability. "You're confident I can't break this?" I asked, half joking. AJ laughed. "I've done way worse to it." But why not just use a shovel? The answer lies in the moon's low gravity. A lightweight robot designed to fit in a rocket becomes even lighter on the moon, making traditional digging nearly impossible without floating away. AJ's team solved this with a genius design, counter-rotating drums that pin the rover to the ground as it scoops, canceling out excavation forces. This machine can dig more than its own weight, an unprecedented feat. Watch as we put it through its paces, navigating trenches and flipping upside down, only to right itself with ease. Once the regolith is mined, the next challenge is turning it into something useful. Enter Robert Mueller, a senior technologist at NASA's Swamp Works, who's pioneering ways to transform lunar dust into solid building materials. The process is deceptively simple. Heat the regolith until it sinters, fusing into a dense, rock-like substance. I held one such sample, a heavy, solid block that felt like it could withstand a hammer blow. "This is just lunar soil baked in an oven?" I asked. "Exactly," Robert replied, "but the real magic happens when regolith is mixed with plastic to create a versatile material for 3D printing. Using a robotic arm equipped with a print head, NASA can produce structures like blast deflection walls or dome-shaped habitat roofs. These aren't flimsy prototypes, they're tough enough to endure the moon's harsh conditions." "You can kick it all day and it won't break," Robert said, demonstrating with a grin. "The beauty? Everything is sourced locally. No need to haul materials from Earth. Just bring the robots and let the moon provide the rest." This in-situ resource utilization, ISRU, is a game changer. By mining and processing lunar materials, we reduce the cost and complexity of space missions. A single kilogram launched from Earth can cost $10,000 or more, so using local resources is not just practical, it's essential. The moon's regolith contains oxides that can be processed into oxygen for breathing or fuel, and water ice in its polar craters can be split into hydrogen and oxygen for rocket propellant. These technologies aren't just for the moon, they're the blueprint for Mars, where we'll face even greater logistical challenges. Imagine a Martian colony printing its own habitats from local soil, powered by solar panels or small nuclear reactors. The moon is teaching us how to live off the land in space, and every breakthrough brings us closer to that red horizon. Stay tuned as we explore how these innovations could transform Mars into a second home. The robots driving this revolution are unlike anything we've seen. Traditional rovers, like those on Mars, are designed for exploration, creeping cautiously across alien terrain. But the moon and Mars demand workers, machines that can mine, build, and repair autonomously. AJ Nick's rover is a prime example. Its robust design allows it to recover from mishaps, like flipping over in a trench. It's really maneuverable and powerful, AJ explained as I navigated the rover through a test course. It can get out of a lot of trouble. This resilience is critical in environments where human intervention is impossible. On the moon, communication delays are minimal, but on Mars, signals can take up to 24 minutes round trip, making real-time control impractical. Future robots will need to think for themselves, using AI to adapt to unexpected challenges. These autonomous systems are already in development. NASA's Volatiles Investigating Polar Exploration rover, Viper, set to launch in 2025, will map water ice in the moon's south pole, guiding future mining efforts. Meanwhile, private companies like Astrobotic and Intuitive Machines are deploying lunar landers and rovers under NASA's Commercial Lunar Payload Services program, proving that the private sector is a vital partner. On Mars, robots will need to be even more advanced, capable of constructing habitats before humans arrive. SpaceX's Starship, for instance, could deploy fleets of small robots to prepare landing sites or extract water from Martian soil. These machines aren't just tools, they're pioneers, paving the way for human settlers. Watch as we delve into the AI and engineering behind these robotic trailblazers. Mars presents challenges far beyond the moon's. Its distance means a one-way trip takes 6 to 9 months, requiring spacecraft that can sustain crews for long durations. Radiation exposure during transit could increase cancer risks, necessitating advanced shielding. On the surface, settlers will face dust storms, low air pressure, and the need for self-sufficiency. Yet the rewards are immense. Mars's soil contains water ice, and its atmosphere, though thin, is rich in carbon dioxide, which can be converted into oxygen and fuel. NASA's MOXIE experiment, flown on Perseverance, has already demonstrated oxygen production on Mars, a critical step towards supporting human life. Meanwhile, SpaceX's plans for a fully reusable Starship could slash launch costs, making frequent missions feasible. Building a Martian colony requires more than technology. It demands imagination. How do we create a society on a new world? What laws, cultures, and economies will govern it? Scientists envision domed habitats, underground shelters, or even bio-inspired structures that mimic Earth's ecosystems. Greenhouses could grow crops using hydroponics, sustained by recycled water and nutrients. Energy might come from solar panels during Mars' long days, or small nuclear reactors for reliability. Every solution tested on the moon brings us closer to this reality. The Artemis program's lunar habitats, for instance, will inform the design of Martian outposts, ensuring they can withstand radiation and temperature swings. The dream of a Martian city isn't just possible, it's within our grasp. Keep watching to see how we're planning for life on the Red Planet. At the heart of this endeavor is humanity itself. Astronauts, engineers, scientists, and dreamers are working together to make the impossible real. The Artemis missions will see diverse crews, reflecting a global commitment to inclusion. International partners, including the European Space Agency, Japan, and Canada, are contributing technologies like the Orion spacecraft service module and Lunar Gateway, a planned orbiting outpost. Private companies are pushing boundaries, with SpaceX leading the charge on reusable rockets, and Blue Origin developing lunar landers. This isn't just NASA's mission, it's a collective effort, uniting nations and industries in a shared goal. The human spirit drives this quest. Astronauts training for Artemis face grueling simulations, preparing for the isolation and danger of lunar and Martian missions. Engineers like AJ Nick and Robert Mueller spend years refining technologies, knowing their work could save lives millions of kilometers away. And the public, people like you, play a role too. Your curiosity, your support, and your engagement fuel this journey. As we stand on the cusp of a new era, the question isn't whether we'll reach Mars, but how soon. The moon is our stepping stone, Mars our destination, and the stars our future. Stay with us to the end to witness the dawn of humanity's next great adventure. The path to Mars is fraught with obstacles, but each challenge is an opportunity. Launching heavy payloads remains costly, though reusable rockets like Starship are driving costs down. In 2025, SpaceX's successful Starship orbital tests have proven the concept, with plans for lunar missions by 2027. Radiation shielding, life support systems, and long-term food production are still hurdles, but solutions are emerging. NASA's Advanced Food System program is developing nutrient-dense crops for space, while radiation-resistant materials are being tested on the International Space Station. On Mars, dust mitigation will be critical, as fine particles can clog equipment and endanger health. Innovations like electrostatic dust repellents are already showing promise. The timeline is ambitious but achievable. Artemis 3 aims to land humans on the moon by 2026, followed by annual missions to build the Artemis base camp. By the 2030s, NASA plans crewed Mars missions, with SpaceX potentially moving faster. International collaborations like the Mars Sample Return mission with ESA will bring Martian soil to Earth for study, paving the way for human exploration. Every success builds momentum, and every setback teaches us resilience. The Moon and Mars are not just destinations, they're milestones in a journey that could take us to the asteroid belt, the moons of Jupiter, and beyond. Join us as we explore the triumphs and trials of this cosmic odyssey. As we stand in 2025, the future of space exploration has never been brighter. The moon, once a distant memory, is now a bustling hub of innovation, preparing us for the red planet. Mars, with its Earth-like allure and daunting challenges, beckons us to push the boundaries of what's possible. From robots that dig in low gravity to 3D printers crafting habitats from alien soil, the technologies we're building are transforming dreams into reality. But this isn't just about machines or missions, it's about us. Humanity's unyielding drive to explore, to create, to endure. The journey to Mars will test our ingenuity, our courage, and our unity. It will demand the best of us, from the engineers designing rovers to the astronauts who'll walk on alien worlds. And it needs you, your curiosity, your passion, your belief in a future where humanity reaches for the stars. The moon is our stepping stone, Mars our next frontier, and the cosmos our ultimate canvas. Stay with us until the end, because this story isn't just about where we're going, it's about who we'll become. Energy is the lifeblood of any off-world colony, and both the moon and Mars present unique challenges in keeping the lights on. On the moon, the 14-day lunar night plunges the surface into darkness, making solar power unreliable without massive battery storage. NASA is tackling this with small nuclear fission reactors, like the Fission Surface Power Project, which aims to deliver 40 kilowatts of continuous power, enough for a lunar outpost, by the late 2020s. These reactors are compact, safe, and can operate in the moon's extreme conditions, providing a steady energy source for habitats, rovers, and scientific experiments. On Mars, the challenge is different. The planet's distance from the sun means solar panels produce less energy, and dust storms can block sunlight for months. Nuclear power is again a frontrunner, with concepts like kilopower reactors offering a scalable solution. Imagine a Martian base humming with energy, powering life support systems, greenhouses, and even fuel production, all while withstanding the planet's harsh climate. These energy innovations are being tested on Earth and the moon, ensuring we're ready for Mars's demands. Stick with us to see how we're harnessing the power of the atom to light up the cosmos. Living on the moon or Mars means rethinking how we sustain life. On Earth, we take food and water for granted, but in space, every resource is precious. NASA's Advanced Food System program is developing ways to grow crops in controlled environments, using hydroponics and aeroponics to produce fresh vegetables like lettuce, tomatoes, and even strawberries. These systems recycle water and nutrients, minimizing waste, a must for long-term missions. On the moon, water ice in polar craters can be mined and purified for drinking or split into oxygen and hydrogen for breathing and fuel. Mars, too, has water ice locked in its soil and polar caps, which robots could extract and process. The MOXIE experiment on Perseverance has already shown we can produce oxygen from Mars's carbon dioxide-rich atmosphere, a breakthrough that could supply both breathable air and rocket propellant. Picture a Martian greenhouse glowing under artificial lights, where astronauts harvest fresh food while robots mine ice beneath the surface. These systems, honed on the moon, are paving the way for self-sufficient colonies. Keep watching to discover how we're turning barren worlds into habitable homes. Beyond technology, colonizing Mars raises profound questions about what it means to build a new society. Who gets to go? How do we govern a Martian colony? What rights do settlers have? And how do we ensure equity in a frontier millions of kilometers from Earth? These aren't just hypotheticals, they're pressing issues as we plan for a multi-planetary future. NASA and private companies like SpaceX are already grappling with these challenges, consulting ethicists, sociologists, and legal experts to shape a framework for off-world living. A Martian colony could be a fresh start, free from Earth's historical baggage, but it risks replicating old inequalities if we're not careful. International agreements, like the Outer Space Treaty of 1967, prohibit claiming celestial bodies as sovereign territory, but they don't address private corporations or long-term settlements. As we build habitats and mine resources, we'll need new rules to balance cooperation and competition. Imagine a Martian council, diverse and inclusive, drafting laws under a red sky. This is more than a technical challenge. It's a chance to redefine humanity. Join us as we explore the ethical frontier of our cosmic journey. Artificial intelligence is becoming the backbone of our journey to the stars, transforming how we explore and settle extraterrestrial worlds. On the moon and Mars, where real-time human oversight is limited by communication delays or harsh environments, AI-driven systems are stepping up as critical allies. These intelligent machines don't just follow pre-programmed instructions, they adapt to unforeseen challenges, making decisions in real time. For instance, NASA's Viper rover, launching in late 2025, uses AI to navigate navigate the moon's treacherous terrain and identify water ice deposits with precision. On Mars, AI will be even more vital, enabling rovers to autonomously avoid obstacles, optimize digging operations, or manage habitat systems during dust storms. Imagine a fleet of AI-powered robots working tirelessly to prepare a Martian landing site, analyzing soil composition, and adjusting their strategies without waiting for Earth's input. These systems learn from each mission, growing smarter and more efficient. Stay with us to explore how AI is not just supporting but leading the charge in our cosmic expansion, ensuring our first steps on Mars are as precise as they are bold.